Okay, independent events. We showed you how to find the probability of things occurring. For example, if I rolled a 6-sided dice, how would I find the chance of rolling an even number? How many events on that dice are associated with an even number? 3. 2, 4, and 6. 3 over, what's the total number of 6? 3 over 6, there's a 50% chance, which makes all sense to you, okay? But now what our focus in is year 10 is combining events. So far we've only considered the probability of a single event occurring. But compound events are situations involving events that are combined in a certain outcome. At this year level, we consider independent and dependent. Your lesson today will be for independent events. So 2 events are independent if the occurrence of each event has no effect on the occurrence of the other. So they're completely separate. If it makes sense to you, don't bother getting that, but that's the definition of what an independent event is. What you need for your cheat sheet is this, though. If 2 events, A and B, are independent, then the probability of A and B occurring is equal to the probability of A times by the probability of B. And this can extend to any number of independent events which you'll be tested on. The probability of A, B, and C occurring, if they're independent, is just the probability of all these times together. So can you get the formula, please? It's a bit stuffy in here. Does anyone mind if we turn the aircon on? Fine. Did you press that button? Oh, damn it. I'll have to remove that. So just those 2 formula, only a couple of quick examples. Probability of A and B occurring, given they are independent, is PA times by PB. Right, so let's do a basic example here. A coin is tossed and a dice is rolled at the same time. We assume that it's a normal dice. Find the probability that a tail and a 2 is the result. This little starred thing here, you don't need to write this, but this is me encourage you to think about it. Is the roll of the dice going to affect the toss of the coin? Nope. No? So they're going to be independent. So my formula here is going to work. So the probability, this is what I'd encourage you to do the working out to look like, to remind yourself. Probability of tail and 2 equals the probability of a tail. What is the chance of flipping a tail? 50. Yep, so 0.5. Work in decimals, work in fractions if possible. If you wrote 50, your answer's going to be completely out there, okay? Work in decimals. Times by, what's the chance of a 2? 1 over 6. So we have a little situation here. Because, hey, we don't know how to times decimals and fractions together, but as a smarter group of people, is there a way that I could write 1 over 2? And then, how do I multiply fractions? The top by the top and the bottom by the bottom. So 1 times 1 is 1, 2 times 6 is 12. I will accept that answer. 1 over 12 chance. If your question says, can you express it as a percentage, you could go 1 divided by 12 is a decimal. What percentage would that be? 8.33. Good. So which is approximately equal to 0.0833 recurring, therefore 8.33% chance of that occurring. Slightly basic example there. I'll give you a few moments to get that example down, please. A coin tossed and a dice rolled, independent of each other. Now scroll up so people can start drawing the bags. That's example 2 there. Yes?
Are there going to be color-related questions on the test?
Oh, yes, sorry.
Like
On the test, it will be written out.
Yeah.
I'll draw that there. Thank you for reminding me. That my apologies. I forgot about that. So there's and here does that help? Yeah. A marble is selected at random from each of the bags below. Draw a tree diagram to display the possible outcomes. Find the probability of getting a green and a yellow. What in this situation makes the events independent? There's two separate bags, okay? Me picking out a marble from this one isn't going to affect what happens in here. If there was one bag and I grabbed a marble and then didn't put it back, would it be independent? That would be dependent. That's what we're heading towards. So draw a tree diagram. A tree diagram is all those branches. So if I look at bag A, this is my first level of tree. Bag A, how many branches would there be? 2. I'm glad, because most classes will say 5 branches. No, what are the only 2 options in that first bag? Green and yellow. Green, yellow, and you can put the chance of that occurring straight away. If I've got 3 green in there, 3 out of 5, and yellow, 2 out of 5. We have a separate bag now. Is it still 2 branches? It's 3 this time. So 1, 2, 3, green, yellow, red, and the chances are 4 out of 1, 2, 3, 4, 5, 6, 4 out of 7, 1 out of 7, 2 out of 7. It's a good time to check as well, because in our examples for the timeline exercises, they're going to be sort of basic, okay? Always check this, because if there's 7 different results, does that 4, does that 1, does that 2, does that add up to 7? 4 plus 1 plus 2, 7 over 7. So these chances are covering all possible opportunities here, okay? What would I do for the other branch, for going yellow first? Would it be the exact same?
Yeah.
Yeah, so because I've got the device, I'll just copy and paste that. Maybe that was a bad idea. What could I do? I needed to... Oh, look at that. The teacher knows how to use technology. My God. Bag B. B, find the probability of obtaining a green marble and a yellow marble. This is harder than it looks. Because is there only one way to get a green and a yellow marble?
Nope.
Has the question specified that you must get a green first and a yellow after? Be careful. I'm going to try to troll you. So all I care about is that I have a green and a yellow. So I'll get a green,
6 out of 35 and
yellow,
3 out of 35.
green and yellow. Is there another option for green and yellow?
Green.
Yellow and green.
Yeah.
So we're going to combine 2 things here. The first is going to be 3 over 5 times by 1 over 7. And the second option is 2 over 5 times by 4 over 7. So then the top's going to be 3 over 5 times 7, 35. Plus, what's 2 times by 4? 8 over... Do we have the same denominator here?
Yep.
Am I allowed to add fractions when they have the same denominator? 8, 9, 10, 11, 11 over 35. Is that cancelable down? 11 over 35. Is there anything common to those? 11 is a prime, I think, so it's not going to have any common factors. So leave that. Please make sure that you cancel down fractions as much as you can. It's worth them up. Okay? So you have an 11 in 35 chance of obtaining a green and a yellow marble. Okay? So what I'll do is I'll scroll down here so you can see that full example. Other side. Get that example. Can you finish? I didn't give you enough time on Monday because I was teaching for longer than normal on the Monday. Finish any leftover work from exercise 16A, then 16B.1 here. If you finish early, I'd suggest that you can go outside, go down into the quadrangle to practice your talks with people.